Hello, sixth grade math students. We are moving into our next unit, which is our data and statistics unit. Today, being our first day in this data and statistics unit, it's an intro kind of day, but we are going to move pretty quickly into some topics. So we'll talk a little bit about statistics as a whole. We're going to the two main things you should pull from today. You should be able to tell us what a statistical question is, which will make sense in a little bit, I hope. And secondly, we're going to be looking at our first way to display data, to visualize data, rather than just looking at a bunch of numbers all bumbled together. How can you look at it more cleanly? And that's going to be through dot plots. Woo! The thing we're going to do today is, what is a statistical question? So let's start there. Statistical questions have to do with this first phase of what statistics are, and that's collecting data. You need data to even be able to make a data display and to make decisions and whatnot. So we collect data by asking questions, and the questions we need to ask need to be statistical questions. So what does that mean? A statistical question is a question that will give us a variety of answers instead of just one single answer. So we want a question that's going to give us multiple answers. For example, a question that might have been asked for this data set is, how many passes did each Premier League team complete each game during the course of the season? There is not one answer to that. There are many different answers. That's why we see many different numbers in this big graph of numbers. So we're going to go through a couple different examples. I'm going to go through a couple different examples right now to try to highlight the difference between what a statistical question is versus a non-statistical question. So I made a little chart, and one by one we'll go through. So one example of a statistical question, one that will give us a variety of answers, more than just one answer, is, how many minutes do sixth grade students spend on schoolwork each week? There are many different answers to this question. Some of you zip through your work and try to get it done in 10 minutes. Others of you are mindful of what you're doing, or might work at a slower pace, or might TikTok every 10 seconds in between assignments, and so it takes you longer to get things done. Whatever the case, this is a statistical question because there are many different answers. There is not just one answer to this question. This question will generate a variety of answers. Now let's take that same question and twist it a little bit to make it not statistical. How many minutes did Lord Farquaad spend on homework last night? That is not statistical because that is asking one question about one person, and it's going to generate one answer. If we looked at Lord Farquaad doing homework last night, he spent one amount of time on homework. So no matter who we ask, there's one answer to that question. He spent a certain amount of time on homework last night, if we're asking everyone about the same exact night about Lord Farquaad. Anyways, let's go to some other examples. Another statistical question would be, how much do bags of chips cost at the grocery store? Well, what type of chips? Are you talking about Doritos? Are you talking about pretzels? Are you talking about, I don't know, some other kind of chips? It depends on the type of chip. Depends on the store you're shopping at. It depends on the size of the bid. A lot of stuff. Anyways, there's a lot of answers, a variety of answers that will be generated by that one question. Therefore, it is statistical. Let's look at another non-statistical question. This is not related to the chip question, totally different. How many countries start with the letter Z? This is not statistical. There is one answer to that question. If we looked it up, every one of us would come to the same conclusion. There are the same number of countries that start with the letter Z no matter who you ask. So that is not statistical. There's no variety. There's one answer to that question. Last statistical question I come up with was, what are the hair colors of students in your class? Well, there's plenty of different hair colors. Some are blonde, some are brunettes, some have black hair, some have whatever. There's plenty of different answers. There's not just one. Therefore, it is statistical. The last non-statistical question I came up with was, how many feet are in a mile? No matter who you ask, there is one answer to that question. There is a finite amount of feet in a mile. You can't change it. There is one answer. How far is Earth from the moon? There is one answer to that question. I'm sure you could think of more non-statistical, but those are not going to give us variety. They're not really going to give us anything to look at, to analyze, to organize, to interpret, because there's only one answer. Statistical questions, though, give us data that we can then organize, analyze, and interpret and make decisions about. So statistical questions are what we're going to be focusing on this unit. And so the first thing that we all want you to be able to do is to be able to look at a question and tell, is it statistical? Beyond that, we want you to be able to come up with statistical questions. At some point, you're going to be asked to create your own data displays. And so you're going to need a question that you can gather data around. And you need a statistical question. You need a question that's going to get you a variety of answers. Statistics are about a variety. All right. Take a deep breath. We are now going to shift gears to the second part of today's lesson. The second thing we are going to look at is data display number 1 for this unit, which is dot plots. Dot plots also go by the name of line plots, and there's a reason for that. I'll explain in a second. So dot plots. These plots use a number line to show the amount of times that a value in a data set occurs. So let's say we asked that a question. Let's see. What question could we ask? Let's say, how long did it take the students in your class to run a 100-meter race? That's a statistical question. There's going to be a lot of different times. Some people are faster, some people are slower, and you might display the data once you've got all of your answers and organized it in a display that looks like this. This is known as a dot plot or a line plot. It's called a dot plot because there is one dot that represents every data point. So the first thing I'd like you to make sure you understand is that in a dot plot, every dot stands for one piece of data. So this would be one student. This would be one student. This would be one student. So we've got a lot of different students represented in this dot plot. It's also called a line plot by some because it's created using a number line. A line is used to create a dot plot. Most times you'll hear a dot plot, but you might hear line plot. We're going to call it dot plot for the most part. But every dot represents a person. So this dot might be me running it the fastest in 13 seconds flat, and then we've got some people who did it in 13.2 seconds. There are 2 different people, 1, 2. So every person gets a dot. Nobody did it in 13.1 seconds, but there's still a line that represents that. So 13, 13.1, 13.2. One person did it in 13.3, but one thing to point out is you don't skip spots. Even though no one did it in 13.1 seconds, you should be going in consecutive counting order when you create your line plot, which we'll do together in a second. So dot plots show us 2 things in a data set, 2 important things. They show us, number 1, how spread out a data set is. What do we mean by that? We mean it shows us the range. This data ranges from someone running it in 13 seconds, and this spreads out all the way to 13.9 seconds. So it shows us how spread out our data is. And this is pretty cool because instead of having to look at something like this, and you can't even figure out what the smallest and the biggest numbers are, you can instantly know in a dot plot what your biggest number and your smallest number is. It shows you the spread quite nicely. It's a very nice visual. And it also shows you the distribution of your data. What do we mean by distribution? Well, I can see within a second where the most dots are. I can see where there's not really a lot of dots. I can see where there's kind of a gap in the data, but it shows me how the data is distributed very nicely. I can see that most people tend to run a 100-meter race, at least in this class. somewhere around 13.8 seconds. Somewhere in here, that's where most of the data is distributed. So dot plots are nice because they show you the spread, they show you the distribution of the data, and it's very easy for anyone to look at that and pick that up. So the last thing that we're going to do today, and I promise this is the last thing, I know it's a long lesson, we are going to go through an example problem where we create our own dot plot. And so to do that, we're going to pretend that you're in Mr. Trench or Miss Wiseau or Miss Janakos' science class, and they are asking you, what is the mass of a typical mouse? Weird question to ask, but we're going to roll with it. So what's the typical weight of a mouse? So first off, that is a statistical question because mice don't all weigh the same. You got big mice, small mice, somewhere in between, a lot of different weights of mice. So there's our cute little mousey, and you and your buds, your pals, you go and you collect some data. You get 25 different mice. You weigh them on a scale. We're going to say that you weigh them in grams. That's what my data plot says here, so their mass in grams. And 25 different mice, you record their weights, beautiful. But this is hard to make an answer to this question. What's the mass of a typical mouse? I don't know, there's numbers all over the place here. So one way that you could make this more easy to interpret and visualize and understand is you could display the data in a dot plot, which is what we are going to do. We're also going to then identify some key things that we see in the dot plot. But the first thing we have to do is make a dot plot. So here's how you will make a dot plot. The first thing you need to do is you need to create a number line. And now I'm going to create the dot part of my dot plot. I am going to use a dot to indicate every value in this dot plot. So mine's not going to be pretty because it's kind of hard to draw in here, but I can see that there are two 18s. So 1, 2. And while I'm doing this, I'm going to talk to you about a couple key things when you're making a dot plot. You'll notice that every dot is approximately the same size. And the reason is, let's say you had one of your columns where you had dots that were like massively bigger than the others or way smaller than the others. Then it doesn't really create a fair comparison between all of the numbers because one of the towers of dots might look shorter than another when in reality it's the same size or bigger, and you just drew too small of dots. So you want to try to make them all the same size so that you can actually make a useful data display. All right, I'm going to speed this up and create the full dot plot, and then we'll come back and talk about it. Okay, welcome back. So here is my completed dot plot. I tried my best to make sure that the dots were all about the same size so that all of the lines that are created by these dots are fairly even and then therefore useful when we're comparing the data. So I can see pretty quickly that there's... Let's go back to the question first. What is the mass of a typical mouse? So to answer that, I want to see where most of the data is located, and I can clearly see most of my data is located in this area right here, right? So one word that you're going to be referencing today in your assignment, and you should keep in the back of your mind going forward, is the word cluster. And most of you can understand what that word means without much explanation. A cluster is where most of something is. It's where you'll see a bulk of things. So I see the data is clustered here. The majority of the points are in this location on the graph. So this I'm going to label as a cluster on the graph. Another thing that you might be asked to identify in a line plot is a peak. A peak in the data. A peak is where the highest point or points are. And in this, there is one peak, and that peak is right here. And it makes sense that the peak is located in the cluster. Most of the points are in this area, and the data kind of peaks right in the middle of this cluster around 20 grams. Most of the mice that were weighed 20 grams or somewhere around there. Um, the last word that you might be asked about is, do you notice any gaps in the data? So a gap is an interesting thing because it tells us that the points that are on either side of the gap might be a little funky. There might be something up with those. So most points are clustered here. We see a peak in the data, and then for some odd reason, there is a gap in the data right here. And that might lead you to, if you're really analyzing this question, why are there these three mice that weigh so much more than the bulk of the others? There's three mice that weigh 27 and 28 grams, and I don't know, one, two, three, maybe they have, I don't know, who knows? I can't even begin to tell you why. But I can now successfully answer my science teacher's question. What is the mass of a typical mouse? Well, according to the data that I gathered, most of the data are clustered around 20. If you're doing the math, actually, 65% of the mice have a mass that's either 19, 20, or 21 grams. So it's pretty reasonable to come to a final conclusion that a typical mouse has a mass of about 20 grams. Anyways, this was a silly example, but it's a good way, an intro way, to look at what is a dot plot, why is it valuable, how do you create one, and what are some of the things that you can glean from looking at a dot plot. So today you're going to be doing just one example, one dot plot in your work, but pay attention to these things. We're going to ask you to identify clusters, peaks, gaps, and going forward, we'll dig more into data. This is just day one. Good luck with it. If you have questions, please ask them, and have a superb day.